Hello, my name is Setun. I'm the moderator for today's Innovation to Practice session. It's 2 p.m. in Singapore now, and good afternoon to everyone who is in the same time zone as Singapore, and for everyone else who's elsewhere in the world watching this live, good morning and good evening. First of all, I warmly welcome you to today's session. We are very honored to have three distinguished speakers with us today. Dr. Lim Mong Hu and Dr. Sarah Ting. Both of them are from the Water Quality Department of the PUB in Singapore. The Water Quality Department sets the water safety management plan, addresses emerging issues and ensures water quality both raw and treated in Singapore. They have established a comprehensive and robust sampling and monitoring programs to maintain water quality from source to tap. And we also have with us Dr. Xiao, who is a research fellow from the Yangtze River Monitoring and Scientific Research Center in China. Welcome, distinguished speakers. First of all, I would like to invite Dr. Lim Mong Hu to speak first to share with us the Singapore case study on smart water monitoring. Dr. Lim, please.
Hi, everyone. Good morning, afternoon, or good evening. So what I will do is I will start with a short presentation on why we need to monitor water quality as an introduction for Dr. Tang and Dr. Xiao to talk about some innovative solutions for water quality monitoring. Okay, why do we want to spend time, effort, and resources to monitor water quality? To try to get to the answer, let us look at some major water contamination event in the world. So we have this 1993 cryptosporidium outbreak in Milwaukee caused by contaminated surface runoff and inadequate removal of cryptosporidium oocysts at the water treatment plant had resulted in more than 400,000 residents became ill and more than 100 people died. The associated cost of damages was about 96 million, which was a very substantial amount at that time in 1993. Year 2000 Walkerton tragedy is one of the world's largest outbreak of E. coli 0157H7 disease, and it was also the worst public health disaster involving municipal water supply in Canadian history. The tragedy was caused by contaminated runoff from cattle farms and inadequate disinfection at the water treatment plant, resulted in at least 7 people died and more than 2,300 people became ill. The estimated cost of damages was 155 million. In 2014 West Virginia chemical leak. This was a case of chemical leak from a 48,000 gallon corroded chemical storage tank. And the chemical leaked into Yangtze River, which is the source water for the drinking water supply. 300,000 residents were affected, and the governor declared state of emergency. In 2014 Toledo water crisis, microcystin, which is an algae toxin, was present in drinking water supply. 400,000 residents in Toledo City in Ohio were told not to drink the tap water. The incident was caused by algal bloom in Lake Erie, and Lake Erie is the water source for the drinking water supply. Okay. So this is a recent case of water pollution, again at the source water, affected the water supply to 250,000 households in Hanoi. While in Singapore, we are not spared to. Our risk of water contamination can come from eutrophication. Eutrophication is a phenomenon of high nutrients loading that will cause algal bloom. Then the algal bloom, the risk of algal bloom is that the algal toxin may be released by algae. So other cases, other risks are like illegal discharges and accidental spills. So looking at all these incidents, we may ask, are water contamination events only a few and far in between? But the answer is no. And media reports and data show that there are more than 3,000 recorded cases of spill in a year in US, and this number is for reported cases. So we can expect that the actual total number is much more than this. So the conclusion is a water contamination event can occur anytime, anywhere. And no matter how short-term the disruption of water supply, the psychological, public health, and economic impacts are significant. And each incident will undermine the public confidence in water safety. So we need to monitor water quality to enable us to detect and prevent water contamination, and also to maintain the water quality within satisfactory levels. And this will bring benefits of public confidence in water safety, enhance environmental assets, and supporting national socio-economic activities. While traditional water quality monitoring approach is sampling and lab tests, but with technological advancement, use of sensors and innovative application of advanced technologies has increasingly gathered more interest. One example is the Algal Pro project, which is a collaboration between PUB and SIWWW. And Dr. Teng will elaborate more on this. I'm going to end my presentation with these slides on future challenges. The world is forever changing, and with climate change, more chemicals being kind of new chemicals are developed and being introduced to the water environment, and increasing public expectations, the landscape of water quality monitoring will inevitably become more complex. So we need to balance the public expectation and our resources for water quality monitoring. And we need to continue to explore innovative solutions for efficient and effective water quality monitoring. Thank you.
Thank you, Dr. Lim. That was most insightful indeed. Dr. Lim is actually the Chief Specialist in the Water Quality Department at PUB. Next, I would like to invite Dr. Sarah Teng. She's the Director of the Water Quality Department at PUB. And we would like to invite her now to share her insight further. Dr. Teng, please.
Thank you. Thanks, Dr. Lim, for the overview on the importance of water quality monitoring. On these innovations to practice platform, I will expand further on two specific examples how PUB actually leverage on some of these I call the smart platforms to conduct biomonitoring. The first example I will share on how we utilize real-time fish monitoring to check any acute toxicity effect in water. And the second example that I'll be sharing will be on the AI-driven platform for monitoring phytoplanktons as part of our water quality assessment. Next slide, please. Yeah. So in PUB, we have put in place numerous online sensors to monitor the water quality from source to tap. And these are sensors largely to monitor the response of different surrogate parameters, such as pH, conductivity, chlorine, etc. For a complete water quality monitoring strategy, we actually complement these physical and chemical parameters with fish monitoring. whereby we actually use fish like tiger barb as a surrogate to measure acute toxicity effect in water. These sensors are placed in key installations within our distribution system, but many of such installations are actually remote and unmanned. Hence, back then, we used CCTV to send images of the fish tank to our control center, whereby they will be viewed manually 24/7. This is very labor intensive, and staff at the control center actually needs to constantly monitor the CCTV images at all times. The images are also not of very high resolutions either. And the other disadvantage of such approach is that the system does not generate auto alert when there is fish there. So we need to innovate how we do such monitoring. Next slide, please. We first fabricated the first prototype for real-time fish activity monitoring system back in 2009. We commonly term it as FAMS, the Fish Activity Monitoring System in PUB. The fish activity, specifically, we are actually monitoring the number of fish there, is actually monitored 24/7 by such system. And we are able to send alert based on the predetermined threshold level. After we fabricated the first prototype in 2009, we have several rounds of, we have improvised the earlier prototype several rounds. And the latest, especially actually to make it more robust for unsheltered location, the latest version that is developed with our local partner SIWW is actually termed as the Aquatech. This version is vastly improved in terms of enhanced data analytic capability, which also encompass fish behavioral analysis. We now use this Aquatech in our entire drinking water installations, but for the raw water monitoring, we are still using the conventional fish tank with CCTV images sent to the control center. I will share more about our current work with SIWW as well to how to improvise this Aquatech to also monitor fish activity in the raw water metrics. Next slide, please. So what I would like to share here is a typical example of images of a fish death during a fish kill incident. What you see here is that over time, the number of fish deaths accumulated, and the system is able to quickly send the alert to the operators based on the threshold, preset threshold number. But at the same time, in tandem with the alert, the system will also capture the water samples so that we can do further laboratory analysis to determine the cause of the fish death. Fortunately, in this case, it was not known to be due to any external contaminations. The cause of the fish death was later known to be related to some changes in the operation, which actually led to supersaturations of fine air bubbles in the supply, which indirectly impacted the fish. Actually, throughout our history of monitoring, we have not detected any external contamination event. But what this incident shows us is that such monitoring is very sensitive. It allows us to quickly check the water quality to ensure water safety and to rule out external contaminations. Next slide, please. Earlier, I talked about we have currently deployed Aquatech in all our drinking water installations. But for the raw water, we are currently working with SIWW. The challenge is to produce high-resolution image in a raw water context. So currently, in these test bedding projects with SIWW, we are actually deploying, validating it for raw water metrics up to 120 NTU turbidity level. The result so far has been very promising. The system is able to track and count the number of fishes rather accurately. I hope we can share more in near future when the study is concluded, right? So now let me switch gear. Next slide, please. To another system that I talked about earlier is to have an automated platform for phytoplankton analysis. Traditionally, this phytoplankton analysis is being done by collecting water samples, both raw water and treated water, and whereby it will be sent to the lab, we'll concentrate it, we'll preserve it before it is manually checked under the microscope. So we need skilled operator, trained analysts to be able to identify the diverse species of the phytoplanktons, as well as to manually count. This process, again, is laborious, is time-consuming. So as part of the solutioning, PUB has started to explore two automated platforms that use either image analysis still image analysis or video analysis instruments. Machine learning is also incorporated in this system. And the machine learning is incorporated based on library of images collated from our local marine and freshwater samples. These both platforms that I'm going to share briefly later are still work in progress, and they are yet to be operationalized. I will introduce them briefly. Can I have the next slide? Thanks. So the very first system that we explore is actually with what we call the Imaging Flow Cytoboard, or IFCB in short. This is the first platform that we is validating through a collaboration study with the Woods Hole Oceanographic Institutions and McLean Research Lab. The system actually used the combinations of video and laser-based flow cytometry to enumerate or to count the different phytoplankton cells. The advantage of such system is that it is laser-based. It can actually give some specificity in terms of the algae cells recognition. We are actually building up the library of the phytoplankton images based on our local marine and the freshwater samples. The system is rather fast. It can actually process a sample within 20 minutes, right? And the next system that we have explored, next slide please, is actually with Zurich, our local partner. And this is what we call the Alga Pro 20. So this Alga Pro system is slightly different from the previous system that I mentioned. This is using digital microscopy to capture images of the algae cells, different from the video streams that I mentioned for the IFCB. This system is relatively faster. It can actually process 15 samples in 4 hours. And it also have a deep learning algorithm built in it. And we are working with our partners, research partner now to build out the database to actually incorporate a local library of phytoplankton images. Because as you know, different countries have different predominant marine and freshwater algae species. So we need to build out our own library for that. Next slide, please. Having said that, we know it is important that we leverage on automated platforms, right, to conduct such laborious and testing processes. It will increase the overall productivity as well as give us a higher throughput in our monitoring. But having said that, we know that there are still challenges exist with all these automated platforms, especially for phytoplankton analysis, because it's not a very straightforward analysis itself. We are actually quite far from achieving the identifications for the entire list of taxa of interest, mainly because the phytoplankton cells, they are very complex in shapes and orientations. Largely, the cells are actually three-dimensional, and many a time they may overlay with each other, which makes the identification harder. But if it's viewed by an analyst, this can be easily resolved. So we need to actually enhance the machine learning in this aspect so that it allows us to resolve and identify accurately the different algae species in the water samples. And with this, I thank you. I end my sharing, and thanks for your attention, please.
Thank you, Dr. That's very insightful indeed. Now, may I please now invite Dr. Xiao from the Yangtze River Monitoring and Scientific Research Center in China to share the insights and experience on implementation of smart water technologies in China. Dr. Xiao, please.
Okay. Hello, I'm Xiao Linjun, staff of the Ecology and Environment Monitoring and Scientific Research Center. And Mr. Wang cannot be here, so I will give the representation on his behalf. And today, I'm honored to participate in Singapore International Water Week 2021 online session and give presentation to all the professors and technicians here about development and application of the planktonic algae intelligence monitoring technology, focusing on Algae Pro, our most innovative AI monitoring system co-developed with SIWW and its application in water quality monitoring of the Middle Route project for south to north water transport. Okay, next up, please. Here is my report outline. First, I will give an overview of research and key technologies of Middle Route water quality monitoring. Then, I will present some main achievements and the key technological breakthroughs of intelligent monitoring of planktonic algae. After that, I will introduce Algae Pro equipment as well as its measured results and comparisons with traditional manual measured results, followed by the latest application of the equipment. In the end, I will give a conclusion of my report. Next slide, please. Next slide. As is known to all, Middle Route of south to north water transport is the lifeline of Beijing, Tianjin, Hebei economic and social development. Accounts for 70% of Beijing's water supply. Scientific assessment, timely warming, and effective prevention of control of Middle Route water quality and ecological risks are important tasks for the safety of drinking water in Beijing, Tianjin, Hebei region. Here are some main topics of Middle Route project water quality monitoring. Our research and development of AI monitoring system belong to topic 3. Key technologies for Middle Route water quality forecasting and risk assessment and early warning. We hope that in the near future, we can integrate the system into a multi-sectoral platform to support a comprehensive monitoring of water quality. Next. This picture present microscope images of different algae. For a long time, identification of algae genus and the number has always been completed by human examination, which is time-consuming and limits the number, frequency, and timeliness of the monitoring samples. Also, this kind of cumbersome and eye-catching work requires professionals with rich knowledge, further causing and the current market techniques to be in short supply. Based on above situation, we've attempted to develop machine examination. The first and the most important step is to construct algae library. Next slide. The research belongs to Middle Route project. So we select about 30 major common algae general in Middle Route area and start consuming the Middle Route algae library. The library is the foundation of our research and development of AI monitoring instrument. We use deep learning, which is the latest and the most potential method in AI technology. This method is like teaching the machine to master certain knowledge. First, you must provide the machine with sufficient teaching materials. The more you teach, the better it can master such knowledge. Here, images in our algae library are the teaching materials. And the more images we have, the higher accuracy an instrument has when analyzing algae samples. Next. And this page reveals the development of planktonic algae monitoring technology. Current method is human examination. As I previously introduced, is time-consuming, labor-intensive, and non-efficient. In the past 10 years, a few teams tried to use computer vision to develop automatic algae image recognition system. But such system software is more like an assisted algae recognition based on morphological differences. Thus, is likely to cause significant and avoids professional errors and lack practicality. Our approach combined multi-depth shooting, deep learning, and automatic expert systems to successfully make Algae Pro a huge breakthrough. It can process a high speed 50 units of samples in 6 hours and still with high accuracy, over 80%. Algae Pro overcomes challenges of skilled manpower shortage and make it possible for unattended automatic monitoring and analysis of algae samples. Next. Here is Planktonic Algae Intelligence Monitoring Device Scheme. First, operating staff need to place up to 50 samples in sample tubes and press operating buttons through the software interface. Then the instrument starts to process. Sample pump works to drive sample flow via transporting tubes to right below microscope, and the XYZ movement controller operates to find and focus algae images. Next, our recognition software started to identify the tube of each images in the field of view and count numbers of types and diagnose water nutrition based on statistical information. All the analysis together with the images are saved to the civil for reference. All the procedures, including sampling, focusing, shooting, composition, regulation, calculating, storage, transmission, and so on, are completely automatically, which is unprecedented and in the practice of algae monitoring. There are three major breakthroughs of Algae Pro. First, it realized the automatic sampling of algae samples. The laboratory version can inject 50 samples continuously at a time, and the field version can be automatically injected. Related technologies have obtained national patent authorization. Second, it realized multi-depth automatic focus scanning under microscope conditions at 400 times, combined with images processing technology to achieve high definition images under microscope conditions. Third, it proposed a new algorithm combining deep neural network technology and expert knowledge for the first time, which optimized the algae recognition model and significantly improved accuracy of algae recognition. Next. Here is a demonstration of Algae Pro measured results. On the right side are left captured images of flowing samples, and the top one is raw image and the bottom one is processed images with labeled boxes and the respective names of each recognized algae. On the middle represents the analysis report of each samples. We can find algae names in Chinese, algae name in English, algae number currently observed, percent of such algae numbers in all algae number currently observed, and algae cells density in the report. On the left is the operation manual. By clicking different bottom, staff can give various orders to the system, including start, pause, tube clean, sample swift, and so on. Next. We did several comparisons between Algae Pro measured results and human measured results. This page demonstrates the algae density comparisons using water samples from different sections of Han River. Blue bars represent human measured results, with orange bars represent Algae Pro ones. We can see the errors of Algae Pro measured results are mostly less than 50% and can even reach incredible 3.7%. The largest error is 20.5%, which is also acceptable. Next. We did not only the density comparison, but also detailed comparisons of different algae percentage composition in each sample. We can see for certain algae like Cimbella and Lavicula, Algae Pro and the human results maintain good consistency. This may be because that the two mentioned algae have comparative obvious features, and we also have sufficient images to train our algorithm. For some algae like Sinedro, the future may be harder to capture, and we are adjusting our algorithm to better recognize such ones. Overall, the errors of algae pro for each algae genus are below 25%. Next. Here is the comparison between Algae Pro and the similar instruments at home and abroad. For reference, standard Algae Pro is the only one which takes industry standard as reference. Well, most of them operate non-standard. For sample injection, Algae Pro is the only one to apply automatic sampling, which allows 50 samples at a time in the laboratory version and continuously sampling in the field, while others all require manual injection. For test magnification, Algae Pro is able to operate at 400 times test magnification, which is the highest magnification, further ensuring its recognition accuracy. In fact, Algae Pro is the only instrument to conduct human versus machine test comparison and maintain an error less than 20%. Therefore, Algae Pro is supreme in industry capacity, operation, convenience, test accuracy. That's why we are confident about this application and further development. Next. And these technology breakthroughs have attracted attentions from mainstream media, including People's Network, Chinese Academy of Sciences, Global Times, Science9.cn, and so on. They are impressed by this innovative research and recognize a huge potential of the future application. Next. We are confident about Algae Pro and its future development. There are several application cases we have been working on to utilize the system, including this. Next. As a summary of this feature, fully automatic monitoring system for planktonic algae based on AI technology has been developed to realize the automatic of the whole process of planktonic algae monitoring. Firstly, future detection method based on a deep neural network and artificial future detection method assisted by the expert knowledge using convolutional neural network model and photoparameter in initialization algorithms. An algae recognition model has been built and realized the intelligence identification of planktonic algae in the middle route of the south to northwest water transfer project. Secondly, with reference to the algae monitoring Microsoft method, it realized the function of monitoring algae sampling automatic and oscillating, mixing, sampling, loading, microfocusing, field of view conversion, counting recognition, statistical analysis, and outputting results and realize multi-depth shooting at 400 times with automatic images synthesis, and the automatic identification rate of algae is significantly improved, and the whole process of monitoring and analysis of planktonic algae in the middle route of the south to north water transfer project can be automated. Okay, thank you.
Okay. Thank you, Dr. Xiao. Very interesting and insightful presentation. Now, I would like to thank Dr. Lim, Dr. Ting, as well as Dr. Xiao for all your presentations. Now we will move on to our panel discussion segment. Perhaps I can start off by asking Dr. Lim first on some issues. Dr. Lim, just now in your presentation, what struck me was you asked this question, all these contamination cases few and far between, And your answer was absolutely no, unfortunately no. Now, given that scenario, can you tell us and our audience, why is water quality monitoring so important?
Yeah, actually I show in the slides, there are a few things here. First thing is water safety is utmost important.
Yes.
If your water safety is compromised, there are a lot of bad consequences. For example, people don't trust your water, so they tend to buy bottled waters. But bottled waters, you know, plastic, you have another problem of plastic. So that's one part, that it's not environmentally friendly with all this plastic around. So second thing is your economic development, your social economic activities, that if your water is not clean, people will go away from water. But you know, water is also part of recreation that that people rely on. Recreation activities will be kind of compromised if your water is not clean, because it can bring disease, and not only cleanliness, about the clarity of water. Disease is also another aspect. Then another aspect is your kind of attraction for investment. That's your economic development. If you are not able to provide safe water, foreign investment would tend not to kind of come to your country, because the water is an important part. Not only quantity, quality is also important. And quality is also kind of assurance for their whatever processes. If you can't guarantee the water quality, and whatever the industrial processes that have to rely on a certain standard or certain clarity of water, there are no confidence that you can do that. So this is the several aspects of water that will impact on you if you don't kind of have some assurance on this water safety.
Right. Thank you, Dr. Lim. I think your answer is very clear. But following from that, how do you view the importance of smart technologies when it comes to monitoring water quality then?
Okay, the other part is, you look at, I briefly mentioned that traditionally when you do monitoring, you take a sample, you go to the lab and you test. But how often can you do that? So the problem is you can't do that. And then when you do this kind of traditional sampling, it just gives you a snapshot at that moment. And you know that the more closely you monitor water quality, the risk of water quality being out of your specification will be minimized. The more you do, the less risk you have out of spec water. How to achieve that, to say that I want to kind of maximize my water quality monitoring? You need smart technologies. Otherwise, you rely on conventional method of sampling and lab tests. You know that you only monitor a very small window of the time frame. But with smart technology, you are able to kind of expand this time frame, because some, like, you know, online system can be continuous. Then your assurance about the water quality is much, much higher assurance for that. So all in all, is trying to minimize the risk and maximize your monitoring period. You have to rely on smart technology.
Right. Okay, thank you, Dr. Lim. Dr. Ting, just now when you were doing your presentation, you discussed the issue, or rather the technology involving Algae Pro. Now, can you tell us how do you think Algae Pro will help in the operational capabilities of PUB?
Yeah, sure. You see, we have raw water samples and treated water samples coming in on a daily basis, where we need biologists, trained biologists to analyze these samples. And with their trained eye, they have to identify the different genera of the algae species. So with the automated platforms like the Algae Pro, we can actually better utilize the biologist's time. So instead of them having to sit down there and spend hours checking and investigating, looking at the microscope, we have a system that can actually do this job. So you know that over time, the test demand is not going to reduce, it's increasing over time. More plants are being built, more pipes are being laid. So the water samples that is coming in is continue to increase. So we have to find a way forward whereby we do not compromise the testing and the monitoring. So this part of using an algal blow will actually allow some man hours to be released so that they can actually focus and focus on other testing as well. So we can actually increase, have a higher throughput. And the system, I believe the system, once it is operationalized, if need be, we can even let it run overnight, 24/7 if we want to. And that will increase further the frequency of monitoring, as what mentioned by Dr. Lim. The more you monitor, you reduce the risk, you pick things up early. But with a human, there's only limited number of samples that you can process per day. So such automated platform will facilitate, will increase, give us a higher throughput in the monitoring and overall increase the productivity of the laboratory.
Right. It sounds, Dr. Ting, it sounds like a very tedious process for your biologists to actually try and identify all these algae samples and things like that. Normally, you know, can you tell us like how long one of your biologists would need to work on this or gain enough experience to be able to identify the specific species and to do the counting?
Yeah, we have, it depends on the level of experience. We have very experienced and skilled biologists. You give them one water samples, they can spend, I think, about 10 minutes. They can scan the entire samples and they can tell you roughly, without the actual counting, what are the key species, any abnormality. But if it's someone who is less experienced, perhaps they need about, I would say, at least half an hour, and to carefully scan through all the entire water samples, and then plus the counting, it can actually take 30 minutes to 45 minutes. Yeah. So it is laborious in a sense, also because it is quite straining on the eye. So you imagine having a person sitting behind the microscope 8 hours every day just to look at the samples. So having an Alga Pro system will definitely alleviate this. Yeah. And then we can do the monitoring more smartly. We can use the human as a QA/QC check from time to time, but the bulk of the analysis are done by such platforms.
Right. So in other words, it will also help eliminate human errors, perhaps due to tiredness or because, you know, the species are quite similar in nature and they may be a so-called misidentification, I suppose.
True. Yes and no. For a trained as analyst, I think the beauty of having a person, a human looking at the microscope is that they can actually adjust and using different magnifications, looking at different dimension aspect of the cells, they can actually do a better identification if need be. If it's a very straightforward morphology, of course the system can pick up easily. So I wouldn't say that using a human will introduce errors in that sense, but true, with at the end of the day, after looking at the microscope for hours, perhaps the counting, this is where the countings may have a little bit of error, but the system will continually, if it's the algorithm, I think it will, the performance will be more consistent. It doesn't matter, the system will not get tired as versus a human. Yeah.
Yes, thank you, Dr. Teh. Dr. Xiao, maybe I can ask you the same question as well. How do you see Alga Pro having helped transform the operational capabilities of the Yangtze River Authority?
As I said, because we take a lot of samples, and the Algae Pro can both save times and the human resource and like, so it can both time saving and improve the accuracy, and it gives us more time to do something like to take more samples or to yes, and like.
Right. Would you say that AlgaPro actually is actually more accurate and faster in terms of meeting the your operational needs?
Yes.
Yeah. Okay. Okay. Right. Maybe Dr. Lim, can I just ask you, what do you think would happen if PUB and Singapore didn't adopt some of these smart technologies to protect our water resources?
Well, I think these are kind of driven by situation. I wouldn't say that, I won't answer the question. I'll answer directly.
Yeah.
To say that what if PUB don't do that? I'll answer the other way, that PUB need to do that.
Yeah.
Because we have a mission to achieve about water safety. So there's always a mission, you're chasing after mission. Then you find that, like Dr. Tang had mentioned, our waterworks, our water networks, water system expanding because of the socio-economic development. You got more people, your population increase, your industrial activities increase, you need more and more water. So we need more water resource, you need more reservoirs, that we go into like even desalination. With this more and more type of water coming in, we just need to pay our attention in monitoring water quality so that we have confidence that we maintain the safety of water. I think that is the key. Of course, we have to kind of how to do that, what exactly resource to spend on it, right? It has to go through a kind of scientific approach on the risk management perspective. I mentioned that we need to minimize the risk so that we have higher assurance of water safety. So all this aspect is a stream of scientific kind of consideration, right? So you just need to put on, but you know that there'll be a time if you totally rely on human, there'll be a limit, the limitation. So with the advancement in technology, you can actually leverage on all this technology advancement to kind of minimize the risk. So that is what PUB is trying to, is continually doing it.
Yes, I think I've worked with PUB long enough to appreciate that is the objective. I must say that, PUB does really put in the efforts to actually look after the water security in Singapore itself. Dr. Ting, from your perspective, what do you see as, in terms of development and technologies, how do you think PUB will move forward in the near future?
I guess I agree totally with Dr. Lim when he mentioned that it is really serving, ensuring our mission, right? Fulfilling our mission to ensure that water is safe at all times. So the bottom line is really not chasing after the technology. It's really leveraging of the technology to help us achieve our mission. So moving forward in PUB, I would see that more and more we need to leverage on all these various smart platforms to help us to do our job better, better use our limited resources. But at the same time, I think with more of these smart platform coming online, one thing is the data. I think this is one aspect. There will be more and more data generated. And how do we tap? First thing first, we need to ensure the integrity of such data. Secondly is we can also harness a lot more information from such data. This will go in tandem with the adoptions of the smart technologies. So this is my thought for as a PUB moving forward.
Right. Thank you. Dr. Xiao, you just heard from Dr. Ting, the importance of the collection of data. Is it the same for you? Is the collection of data important in helping the Yangtze River Authority deal with the issues that may arise from time to time?
Yes, of course. Data collection is very important because every product needs to set a library, and the more samples it takes, and the more accuracy it will get. Yes.
Oh, okay. Thank you. Dr. Lim, just going back to one other aspect, during your presentation, there was a slide that shows that in the US, there were over 3,000 contamination cases a year in the US. Do you think that this the number of contamination cases would more likely to increase with time or likely to decrease?
If we look at water quality, if nothing happened, we just look at the logic of it. If you don't do anything, business as normal, and when your business expanded, obviously there will be more cases. So that I can't really kind of foresee what will happen, whether increase or decrease. It depends on how much effort they put in, or international community, water community put in to prevent all these water contamination cases. So for example, I'm trying to say, if you just take a country, right, they already have this number, but if just status quo and the business expanded, the industry expanded, so chances are there will be more cases. But if the country take kind of proactive approach and try to do it, for example, some of the smart technologies that we had just discussed, right, to prevent or to kind of arrest the problem before it can happen, right, then all these cases will be reduced. So there's no one single answer. It all depends on how much effort you put in. We know in Singapore, you live in Singapore, we don't have many such cases because we put in a lot of monitoring. So we know when or before the problem arises, we already kind of know the trend, is aware of the trend, then we can take remedy measure to kind of normalize the situation. If you don't know about the trend, you let it develop, then you develop into a crisis. So monitoring is important. So you need to put effort in. So it's kind of inversely proportional. You put effort, you monitor more, your risk of this incident will be less.
Yes. So what you're actually saying is that vigilance is the key.
Vigilance, monitoring, and of course the science behind it is you must know what to monitor.
Yes.
Yeah.
Correct.
Yeah.
Correct. All right. Thank you, Dr. Xiao. Can I also ask you, as far as the Yangtze River Authority is concerned, what are your observations in terms of perhaps environmental damage and contamination?
Algae, fish.
Yes.
And water quality.
Right. Do you think, as far as you're concerned, can you share with us a bit more, like what are the issues that you are facing in China?
问题在中国，你们主要观察这个参数碰到的主要问题是什么？algal bloom. Algal bloom.
Yeah, you can talk about algal bloom. Yes. Yeah, as for your presentation earlier.
Species diversity and pollution.
Yes. Okay. All right. Okay. I think we will now move on to some Q&A from some of our audience. I have a question here that say, and it says, I know there is also challenging on water scarcity due to shortage of resources, high chance of water contamination, and the viewer wants to ask about new water. Do people easily drink new water? Dr. Ting?
If I may clarify here, yeah, new water is a highly reclaimed, treated used water. We have multi-barrier process in place, right? We have filtrations, we have disinfections. Just to clarify here, new water is largely used for the wafer fab industry, right? Where they need a high-grade water. So it is not supplied direct to our tap. There is also amount of new water that is being used to be injected into our surface water reservoir, where it is served to augment the supply, the water resources. Then blended with the surface water, it will get treated at our drinking water treatment plant before supply to the tap. So new water doesn't go direct to the tap per se. Yeah, but regardless, we have every confidence in our new water treatment process. Because it's using RO, is using disinfections, it's a multi-barrier. We have monitoring, very stringent monitoring in place, offline, online testing. So we are very confident in the new water quality.
Yes, thank you, Dr. Ting. I think that's an interesting question because we are rather well known for the new water. There's another question as well here. The viewer says, very nice presentation about water quality. Rightly mentioned that the main important role of utility is to provide safe water. I think steps of water safety plan to protect from source to mouth. Do customers engage to apply water safety plan steps in PUB, or this is fully the responsibility of PUB to apply the water safety plan? Dr. Lim? I think he just wants to know, as far as PUB's water safety plan is concerned, is this solely within PUB's realm, or do we as consumers have a say in it?
Okay, I think this part is in Singapore. I'm talking in Singapore context. Singapore context is PUB monitor water quality from source to tap, right? So yeah, we put in place all the water safety plan right from the source. That means the raw water management, water treatment plant, the water distribution until the tap. So in Singapore context, yes, is PUB maintain and implement, develop and implement water safety plan right to the customer's tap. And maybe at this part, I'll just elaborate a little bit that there'll be some system. There'll be some system that is a bulk system. Maybe in other countries or whatever, a supplier supply water in bulk to a company, and this company distribute water. So in that case, this company may come in to make sure the distribution part of the safety aspect of the distribution part. That means the safety plan of the distribution. And of course, there's another way is towards the end, individual housing estates, right? In some other country, it may be under different management. So the management of the housing estate may have some role to maintain it. So in as far as if the context is in Singapore per se, I would say that yes, I think the implementation of water safety plan from the PUB perspective is right to the tap.
Yes, thank you, Dr. Lim. And I think that Singapore, we're grateful that PUB is doing that for us. We have come to the end of this session for the Innovation to Practice. I would like to thank you, Dr. Lim, Dr. Ting, as well as Dr. Xiao, joining us from China. Thank you so much for your time and for sharing with us your own personal experience. And we are grateful and indeed very privileged to have the three of you here with us today. Thank you, everyone, for joining us, and I hope you have a good day. Bye-bye.
Thank you.
Thank you.